In this mini clip, we'll be solving inequalities. While we answer this question together, you'll be solving a similar problem on your own using the same technique. We're asked to solve the following inequality: 2 less than 8 minus 3x less than 14. What this question is really asking us to do is to find all the possible values of x that would make this inequality true. To find these values, we're simply going to isolate for our x variable. Now we know how to do this when we have equations or equal signs. Now that we have inequalities, all we're going to do is that we're going to treat this less than symbol as though it was an equal sign. We're going to do the same procedure as we would if it was an equation to isolate for x. We just need to be careful when we divide or multiply by a negative number, since this will change our inequality sign. You will see what I mean by this as we go through the solution together. To begin, we're going to eliminate this 8 in front of the negative 3x. To do this, we're going to subtract 8 from this middle term, because 8 minus 8 will give you 0. However, to preserve our original inequality, if we subtract 8 from the middle term, we also need to subtract 8 from the other sides of the inequality. So starting with the left-hand side, we will have 2 minus 8 is less than, now we're subtracting 8 from the middle term, 8 minus 8 minus 3x is less than, and now we will have 14 minus 8. So we just subtracted 8 on all sides of the inequality symbols. Now let's simplify. 2 minus 8 will give us negative 6. Less than 8 minus 8 will give us 0 minus 3x will be negative 3x. Less than 14 minus 8, positive 6, or just 6. I would now like you to try doing these two steps with the question you are given. Here is the answer you should have got. Coming back to our question, we now need to eliminate this negative 3. The operation between negative 3 and x is multiplication. So to get rid of the negative 3, we need to divide this middle term by negative 3, since division is the opposite operation of multiplication. If we divide the middle term by negative 3, we also need to divide the left-hand side and right-hand side of the inequality by negative 3 to preserve our original inequality. So we will divide negative 6 by negative 3, as well as positive 6 by negative 3. Now I mentioned earlier, whenever we divide or multiply by a negative number, we need to change our inequality signs. So in our next step, instead of having less than symbols, we're going to have greater than symbols, since we're dividing by a negative number. Negative 6 divided by negative 3 will give us positive 2. Changing our less than symbol to a greater than symbol. Negative 3x divided by negative 3 will give us positive x. Again, we need to change our symbol here to greater than. 6 divided by negative 3 is negative 2. Whenever we have a variable that's bounded by two numbers, we want to rewrite this with less than signs. So we can do this easily by just rearranging our inequality here. We'll just bring this negative 2 to the left-hand side. Negative 2 is less than x, which is less than, you bring this 2 to the right-hand side, 2. These two lines are equivalent, they're just written differently. We have here now that when our x is between -2 and 2, we know that our original inequality is true. So this is our final answer. We just need to write a therefore statement. Therefore, our range for x is -2 less than x less than +2, or we can write this in our interval notation. Or our x starts at -2 but doesn't equal -2, so we need round brackets to indicate this. Starts at -2 and goes all the way up until +2, but doesn't include 2, so we need round brackets. And here is our final answer. I would now like you to finish off the question you are given. This is what your final interval should be.